Okay, 9.3 is on graphing rational functions. So this is kind of putting everything together that we've done so far. So we're going to learn how to graph things. Okay, so example 1, it says find the domain of each rational function. So we've kind of talked about domain before. Domain is all of the x values that you can put into your function without getting undefined. So the things that make domain weird are things like square roots, you can't have a negative under it. Things like denominators, you can't have 0. Okay, so basically on these rational functions, we want to know what's making your denominator equal to 0. We want to know what makes your fraction undefined. So what makes your denominator equal to 0? Yeah, so it's undefined when x equals 0. So all we're doing is just setting the denominator equal to 0. Okay, so when we talk about the domain, this means that it's all real numbers except for 0. You can put anything in for x except 0. So we write out all real numbers except x equals 0. That's probably the easiest way to write it. Do you guys remember interval notation? I could also ask interval notation. So that would be negative infinity to 0. You skip over 0, so you have a parenthesis, union, parenthesis, 0 to infinity. So we have that. That'd be another way to write it. Do you guys see how that skipped over 0? There was no bracket. All right, so how about this next one? How do you find out when this is undefined? Yeah, try to factor. So I'm going to have x minus 1 times x plus 4. So that equals 0. So that was the denominator factored. When x equals 1 or x equals negative 4. Okay, so we can write all real numbers, or you can do your fancy R. So except x equals 1 and x equals negative 4. Okay. That's the easiest way to write it. Think about interval notation for this. You would have to skip over negative 4 first, then you'd have to skip over 1. So interval notation is really kind of strange on this one. It'd be negative infinity to negative 4, skip over it, so do a parenthesis and then another parenthesis. Then go to 1, skip over 1, and then go to infinity. So that would be interval notation. All right. You're so smooth as well. Vertical asymptote. So this is why we do the finding the domain, because the vertical asymptotes are the lines that are not in the domain of the function. So they're vertical lines that made their a value, so like if x is equal to a, it's the number that made it equal to 0 in the denominator. Okay, so all we do to find the vertical asymptote, you set the denominator equal to 0. So I have 2x plus 5 equals 0. So I get 2x equals negative 5. So x is negative 5 over 2. Okay, so that's a vertical line, right? X equals is a vertical line. And that's like negative 2.5. Oops, I missed it. All right, so at negative 2.5, you're going to have this vertical line. And you're not going to cross that line. Okay, because if you plug in negative 2.5, you get 0 in your denominator, so it can't be a point. So what happens to your graph is it might like come along and go close to it there, and then go close to it there. So it's getting really close to the line, but it's never crossing it. Okay. Okay, they could also both go up. We don't really know what this graph is doing yet, so we'll find that out later. Okay, so that was vertical asymptotes. We're going to talk about horizontal asymptotes. So horizontal asymptote is the line y equals b. So y equals our horizontal lines. And you can get really close to the line at the end, but you don't cross the line at the end. So notice how I said just at the ends. So it can cross in the middle, just at the ends you're not going to cross. Okay, so there's two ways to find your horizontal asymptote. You can do it the long way and the short way. The long way you learn in pre-calc. It involves something called limits, which we're not going to talk about in Algebra 2. We're going to do the shortcut. Okay, so steps for your shortcut method. Number 1, find the term with the biggest degree. It can be in the numerator or denominator. So looking at this first example, what is the largest degree in either the numerator or the denominator? 2. So we circle those terms. Okay, number 2 says divide the coefficients of the terms with the largest degree. So my coefficients are the numbers out front. So I do 10 divided by 5. It says if the numerator or denominator was missing the term, so if I only had it in the numerator, I'd write a 0 in the denominator. If I only had it in the denominator, I'd write a 0 in the numerator. All right, your outcome is y equals something because it's a horizontal line. So it's a y equals. So that's it, y equals 2. Easy. So that means for your graph, y equals 2 is right there. So on the ends of your graph, you're going to approach that line. So I don't know what's happening in the middle. You know, it can cross. But on the ends, it gets really close to that line, but it doesn't cross. That's not really what that graph looks like, so you don't have to draw that, but just on the ends. Kind of like end behavior. We talked about that before. Okay. Okay, so shortcut method on this. So what's your largest degree? 3. So I have 4x cubed. So I'm going to write plus 0x cubed on the top because it was missing it. So whatever it's missing, that largest degree, write in 0. So that means I get y equals 0 over 4. So divide your two numbers, 0 divided by 4. So y equals 0. Because it was missing that degree. Look for your largest degree. All right, next one, what's your largest degree? 5. There's no fifth on the bottom, so I write 0x the fifth. So that means when I talk about my horizontal asymptote, it's y equals 2 over 0, which is, what's 2 divided by 0? Undefined. So what do you think that means about horizontal asymptotes? Right, there's not one. Exactly. So there's no horizontal asymptote. Okay. People always get horizontal asymptote and vertical asymptote confused. They never remember which one's which. So I have, you know how I have cheesy ways for you to remember everything. So here's my cheesy way. Horizontal asymptote, ha. There's a shortcut. So remember that's the shortcut one. So ha. Okay? All right. Yeah, that's it. That's it. That's my cheesy way. All right, slant asymptote. All right, this is the next one. So it says find the slant asymptote for f of x equals x squared plus 5x plus 4 all over x minus 3. So slant asymptotes occur when the degree of the numerator is exactly 1 more than the degree of the denominator. So see how this is degree 2? And this is degree 1. This is exactly 1 more than the denominator. So when that happens, you're going to have some kind of asymptote where it's going to look like a slanted line. Okay. A lot of textbooks don't talk about these, but I know when I was teaching at IU, they did this a lot. So you're going to have to do it eventually. Might as well do it now, huh? All right, so find the slant asymptote.
Exactly 1 more than the...
Exactly 1 more, yeah. All right, so you can find the slant asymptote with long division. The quotient is your slant asymptote. Okay, so let's do our long division. You guys thought we were done with it for good, didn't you?
Wait, if you can factor it, can you just cancel it out? Or no?
Can't factor it. They don't cancel.
Like if you could.
All right. Here we go.
You just do synthetic division.
You could do synthetic division on this one, but most of them, no, most of them you can't because what if it was degree 3 and degree 2? Can't do it for degree 2. So might as well do the long division in your notes, right? All right, so we say, what do I multiply x by in order to get x squared? So I need x. So I write x on top. Once I write it on top, I multiply it by both things in the divisor. So x times x is x squared. x times negative 3 is negative 3x. This is when I always say draw the line, change the signs. Okay, that's because we're subtracting, so I'm adding the opposite. When I do that, I get 8x, drop the 4. Then I repeat my process. So I ignore this last line that I just did. So I say, what do I multiply x by in order to get 8x? 8. So I write 8 up there. Then I multiply that 8 by both things in the divisor. So 8 times x is 8x. 8 times negative 3 is negative 24. Draw the line. Change the signs. You get 28 for your remainder. Okay, that was long division. Ignore your remainder completely. The only thing you're worried about is this, x plus 8. That's your slant asymptote. So it's y equals x plus 8. Okay, so the question is, well, what if it was like degree 4 and degree 3? Would you still get x the first on top? Yeah, you would. It's 1 degree more, so that's why it's a line in the end. It's 1 degree. All right, so that's your answer. That's your slant asymptote. Okay, so what that means is on your graph, you don't have to draw this. On your graph, you have this dotted line, and like the ends of your graph might go along that line. That's all it means. Okay, so just the ends of the graph. Okay, so I don't know if that's exactly what the graph looks like, but that's what the ends look like. All right. Okay. We'll stop.